Welcome back, everyone, to the eCoreAcademy e-learning platform. My name is AJay, back with yet another Algebra 1 video for you all, and today's lesson topic is all about quadratic function basics. So we're going to be looking at the basic properties and characteristics of quadratic functions and their graphs. So before we jump into today's video, please make sure to do 4 things. Please make sure to smash that subscribe button, hit that like button, turn on post notifications, and drop a comment down below. So today we're just going to be looking at the basics of what exactly a quadratic function is, how it correlates with its essential graphs, and what are the basic characteristics of those correlating graphs along with those equations and their properties. We'll also get into some simple transformations of these graphs. So without this lesson, obviously, it would be quite difficult to get into the rest of our unit. We're going to be focusing all throughout the quadratics, that essentially what's going to be wrapping up the end of this Algebra 1 course. One of the last units is going to be all about quadratics. So we're going to be learning the basics, and then we'll move on to translations, transformations, the different types of equations, so on and so forth. So without further ado, let's jump right into it. So quadratics. Let's take a look at the essential quadratics. What exactly is a quadratic function? A quadratic function is an equation in the form of a function. Obviously, it's a type of function that represents a parabola. So this is essentially a function that's going to create a parabola. Just like you have your linear equations that create your lines, your line graphs that go on infinitely in both ends, both sides. Obviously, this new type of function, the quadratic function, is going to create a parabola, a parabolic curve. Parabolas are created when a basic equation is created in which the x value is squared in relation to the y. So obviously we think of a regular linear equation that has to do with y equals x, or y equals some sort of transformation of x, like y equals mx plus b. It's y in relation to just your original x value. However, in this case, you're taking it up to the next power. You're saying that y is equivalent to some form of x squared. So you're squaring that x value now, which is going to give you a parabolic curve. And a parabola is formed in the shape of an upwards or downwards U, essentially. It essentially has a starting vertex, and it goes either upwards or, of course, downwards as well, and it goes infinitely along in one direction. Quadratic is the next power up from linear, so just keep that in mind when you're thinking of your y equals mx plus b, your y equals x, and then your y equals x squared. Y equals x is to the power of 1. It's your singular power. It's your starting power. And then, of course, quadratic is going to be squared. Anything in terms of quadratic, you should think about being squared in terms of, any two variables. So quadratic is the next power up. And also, parabolas continue on forever in one singular direction. So like I said, they're going to continue on two ends. Essentially, think about a U. The ends of the U are going to continue infinitely in one direction, either upwards or downwards. Now let's take a look at some of the key features of the quadratic function. So what are the 4 key features of this quadratic function? The quadratic function parent graph is f of x equals x squared. That's the traditional function, f of x equals x squared. We can think about our linear function, f of x equals x being the parent graph, f of x equals x squared is the parent function. The graph, obviously the quadratic graph, creates a curve known as the parabola. So anything with f of x equals x squared, or any sort of transformation of that, we'll get into that with factors such as a and c being added to the equation. This creates the curve known as a parabola, essentially an upwards or downwards u. Quadratic functions also have an axis of symmetry, so when you're plotting out all the points in essentially you're given a table. Once you're utilizing your equation to create a table to graph your parabola, you'll notice that all the all the values are of an equal distance from a singular vertex, and obviously that single vertex is going to be that reference point. All the points are going to be of equal distances in relation to their term numbers. So then also, when you take a look at the parabola itself, it does have an axis of symmetry, meaning when you split it down the very center, it's identical on both sides. And quadratic functions also have a minimum or maximum point, which is also known as the vertex. So when you think about a parabola, it continues forever in one direction, but essentially that base point of that U of the parabola is your vertex. It's either the maximum point if your parabola is going downwards, or it's the minimum point if your parabola is going upwards. Excuse me. And just to put it out there, quadratics, when it comes to parabolas, these arches and curves, they're everywhere in real life. These are things that, you might think, why do I have to learn about, a parabola? It's not something that's very relevant to real reality. Well, the arch is actually one of the most popular architectural structures. It's one of the most innovative architectural structures from ancient times, from the Roman period. And it's actually surprisingly strong. It can hold up to tons of weight if built properly. So obviously the arch is popular, and it is valuable structure. And then of course we can put that into terms of our own parabola. So key features of the quadratic function continued. Let's take a look at the graphical properties of the parabola. Now that we know, the basic features of the graph essentially and what's written out as key features of the function, let's take a look at the parabola and some of its graphical properties. So the first thing that obviously the parabola has is an axis of symmetry. So your axis of symmetry is going to be what splits your parabola essentially right down the middle. It starts at your vertex and it splits down through the parabola. In this case, it's the y-axis. That's going to be the axis of symmetry. It's a dotted line always. It's just a regular line, continues infinitely in both directions, and it splits your parabola directly in half so that both sides of it are going to be the same. They're going to be identical. If you flip them over onto each other, they're exactly the same. Then, of course, we have our maximum or our vertex. So the maximum in this case is it's going to be a maximum that we're calculating for because our parabola is going to be facing downwards in this case. So the maximum point is that point of reference, our vertex, in which all other values are going to be sloping downwards from. And then, of course, on the left-hand side, since we already split this parabola in half, the left-hand side is going to be an increasing interval. So if we take this interval from x is less than 0, essentially the left-hand side of the parabola, it's going to be increasing over one side. So from left to right, it's increasing going upwards. However, on the right-hand side, from the interval x is greater than 0, it's going to be decreasing from left to right. And that's the property of a parabola. One side is going to be increasing, and the other side it's going to be decreasing. That's always the case. All right, so now that we know what the basic properties of the parabola are and exactly how it looks, let's take a look at some basic transformations of a parabola. So how does A affect the parabola? The basic A is your transformation. There are other extended transformations that we will be looking at as we go on, but A is the most basic transformation that affects the parabola. So if we have the equation f of x equals x squared, we're merely going to add A to the equation, and it's going to be multiplied by x squared. So f of x equals ax squared. So if we're given this original parabola here, what if we wanted to try and make it a little bit more narrow? What if we tried to alter the parabola so that it becomes more narrow? Well, in order to do so, this would be called uh, essentially a vertical stretch. Now, you might be thinking, if I'm trying to make it narrow, aren't I trying to compress it? Well, if you think about it in terms of the y-axis, if you stretch out the y-axis, well, you're essentially going to be making it narrow. You're compressing it horizontally. So yes, it's going to become narrow with a vertical stretch. And when you're trying to stretch it and make it the parabola a lot narrower, that's going to be in terms of your absolute value of your A being greater than 1. So it could be from -1, less than -1 and going onwards, and then greater than 1, obviously. So essentially, it cannot be a fraction between 0 and 1. The absolute value of A cannot be a fraction between 0 and 1 in this case, in order to make it narrower. However, if you wanted to do the opposite, if you wanted to make it essentially wider, and you wanted to basically stretch it out wider, you could do a vertical compression. So a vertical compression is essentially when you take the y-axis and you smoosh it down together to make the parabola a lot wider in this case, also known as a horizontal stretch. And that's how you make it wider. And the way to do that is by altering your A value to make it between 0 and 1, the absolute value. So this essentially means that it's going to be a fraction, it can be a negative or positive fraction between 0 and 1 or 0 and -1. And then, of course, another basic, and obviously this is in terms of our parent function, f of x equals x squared. And obviously when it comes to reflections, f of x equals ax squared. When we're trying to create a reflection, we're taking that original parabola, and we're trying to flip it so that it's essentially a reflection of it, just like you would with a line. You could create a reflection. You would create the reflection if a is less than 0. So essentially, if you have a negative value of a, you can flip the parabola over the x-axis if a is less than 0. All right, now for our last topic, we're going to be looking at average rate of change. Don't worry if you really don't understand this. I'm just going to be glimpsing over this so that it keeps you all stimulated, but we will be going over this in later lessons. So we're going to be calculating the slope of intervals, which is basically average rate of change. So if you're given a specific section of a parabola or any graph in this case that lies between 2 points, you're given a little subsection of a parabola, you can calculate an average rate of change. You can calculate this by calculating for the slope by using the two endpoints to estimate the rise over run. So essentially the average rate of change is the average amount of increase or decrease you're experiencing. And if we think about linear, our lines, the only way to really do that is to essentially mimic it like you're calculating for slope. Now we know that parabolas are curves. However, when you're creating this rise over run estimation with lines, you're essentially creating a line of best fit for the curvature. It's not going to be exact because it is a curve, but it's very close to a line. So if we look at this parabola here, and we're given this highlighted subsection as our interval, we're merely going to take those two endpoints, we're going to calculate the rise over run with the slope formula and see what our average rate of change is for that interval. And that would essentially be our answer, our average rate of change for that subsection. All right, everyone. Well, I hope you guys enjoyed this video today. I really had a blast making this video, and I really hope you, I really hope you all stay with this unit, the Quadratics unit. It's going to be a very interesting unit to end off and round off our Algebra 1 course. So please make sure to like and subscribe down below. Turn on post notifications so you don't miss out on any future uploads, and feel free to comment down below. Check out our website at www.ecoreacademy.org and email us at ecoreacademy@gmail.com if you have any questions. Check out our socials at Pinterest, Facebook, Twitter, Instagram, and TikTok. And also feel free to, share all of our videos through those mediums and check out what really cool content we have out there. And also check us a follow out there as well. I hope you guys enjoyed this video. This has been AJay Raj, and I'll see you guys in the next one. Peace.